Decompression sickness. Our bodies are under pressure all the time. The air around us has mass, and that mass pushes on our bodies. If you have ever flown in an airplane or traveled up a high mountain, you might have noticed changing pressure in your ears. The higher you go above sea level, the less air there is pushing on you. Ears have the ability to balance the pressure inside them, so it is the same as the outside pressure. Small amounts of the gases in air are dissolved in fluids in our bodies. One of the gases, nitrogen, causes problems if the pressure on our bodies is first increased and then decreased. Here's how that works. When we breathe, we take in oxygen and nitrogen from the air. In our lungs, the oxygen and nitrogen dissolve in our blood. Nitrogen dissolves in the blood until the blood is saturated. Under normal pressure, the blood saturated with nitrogen is no problem. When the air pressure is decreased, the blood can no longer hold all the nitrogen and it is released as gas bubbles. The amount of nitrogen that will dissolve in blood depends on the pressure. The greater the pressure, the more nitrogen dissolves in your blood. Can you figure out what happens to the nitrogen when the pressure goes down? If you fly in an unpressurized airplane, the decrease in pressure as you fly higher causes the dissolved gases in your blood to come out of solution. If the airplane climbs slowly enough, the gases have time to come out through your bloodstream slowly, and your lungs exhale the gases. If the airplane climbs too quickly and the pressure drops too fast, the nitrogen comes out of solution as bubbles in your bloodstream. The result is difficulty with muscle coordination, a nauseous feeling, and speech defects. If the bubbles accumulate in the joints, the pain is very severe. Bubbles trapped under the skin cause a red rash and make the skin feel itchy. This sickness most often happens to deep-sea divers. As divers descend into the water, the pressure increases. The longer a diver stays down or the deeper the dive, the more nitrogen dissolves in the diver's body. When the diver comes to the surface, he or she might have to stop several times on the way up. If the diver is brought up too quickly, bubbles will form in the blood. The diver's body may shake uncontrollably. He or she may throw up. The diver will feel pain in the joints and be unable to straighten them out. If the bubbles form in the brain, the diver might become paralyzed. This sickness is serious. It is called decompression sickness or the bends. Relief from decompression sickness is achieved by putting the person in a pressure chamber, increasing the pressure, then releasing the pressure very slowly. This process does not always reverse the damage done to the body tissues. Today, divers who venture far below the sea's surface use computers. These computers tell divers at what depths to stop on the way up and for how long in order to prevent decompression sickness. How low can we go? The deeper one goes in the ocean, the greater the pressure. In recent years, scientists have designed research vessels with thick, strong hulls to withstand the pressure. These have allowed humans to see the deepest, darkest regions of the ocean. How deep have we gone? All depths shown are maximum depths on the chart. Caisson disease and two famous bridges. One of the first reported cases of decompression sickness was not reported by divers, but by 19th century bridge workers. In 1869, James Buchanan Eads began building a huge railroad bridge to span the Mississippi River at St. Louis. Eads was the first American engineer to use caissons to build his bridge. Eads' caissons were huge, watertight, floorless steel boxes. The caissons slowly sank to the bottom of the river as a big concrete pier was built on top. As they sank, pressurized air was pumped into the caissons to keep the water out. Once the caissons hit the bottom, workers could enter through the pier in an airlock on top. Once inside, the men began digging out the riverbed. Slowly, the caissons in the pier on top sank lower and lower into the riverbed. As the Eads Bridge caissons sank, the air pressure increased inside. After they came up from the caissons, workers complained of pains in their bodies. They couldn't stand up straight. The workers began calling their sickness the bends. Doctors named the sickness caisson disease. By the time the bridge was finished, 14 men had died from caisson disease. It was not until 1878 that French scientist Paul Bert explained the actual cause of the sickness, which was nitrogen bubbles in the blood. The Brooklyn Bridge in New York links Brooklyn to Manhattan. The bridge took 13 years to build. Construction of the bridge started in 1870, just 1 year after the Eads Bridge was begun. Like Eads Bridge, the Brooklyn Bridge's construction was marred by death and tragedy. Washington Roebling was the chief engineer of the Brooklyn Bridge project. Roebling was in charge of every part of construction. He even went deep down into the caissons of the bridge. During one of these visits, Roebling suffered from the sickness and became paralyzed. Over the next few years, he supervised construction of the bridge from his bedroom window. Roebling was not the only Brooklyn Bridge worker who suffered from this condition. At least 3 workers died from decompression sickness over the course of construction, and many more were seriously ill.